So, hello to each of you, and thank you for joining what promises, like the first instalment in this series, to be another very content-rich webinar on dams and sustainability, specifically life cycle sustainability assessment. Before we get underway, it gives me great pleasure to introduce Michelle Lino, who will share a few opening remarks. Michelle Lino, as many of you know, is co-founder of ISL Engineering and has 40 years of professional experience dedicated to the engineering of hydraulic infrastructure. He has served as ICOLD Vice President and as President of the French Committee on Dams and Reservoirs. And in 2022, he was elected as President of the International Commission on Large Dams. So over to you, please, Michelle.
Thank you very much, ladies and gentlemen. I'm very happy and honored to introduce this second seminar on dam and sustainability. So the recent World Declaration on Dams and Reservoirs, approved by ICOLD in New Delhi in October 2024, and that will be issued in 2 weeks in Chengdu, highlights the key roles of dams in climate change adaptation and energy transition. In parallel to this declaration, ICOLD launched the Dam and Sustainability Initiative in 2023, bringing together the efforts of several technical committees. ICOLD Dam Sustainability Initiative aims first and foremost to raise awareness among the dam professionals of the need to improve the sustainability and life cycle thinking of existing and new dams. ICOLD is fully committed to a sustainable future, and therefore the ICOLD board strongly supports this webinar series and other actions that our technical committees are planning. Following the introductory webinar 1 in May 2024, for the second webinar, ICOLD has invited a distinguished group of experts to present the key components of the life cycle sustainability assessment and examples of how it is applied in other sectors, with the aim of adapting this methodology to dams and reservoirs. I would like to express my grateful thanks to the organizations that are actively cooperating with ICOLD in this webinar, and especially to the World Resource Forum, the World Bank, the Hydropower Sustainable Alliance, the European Committee of Standardization, EDF, Aquamedia, AmSpec, Technical University Berlin, and many others. I wish you a very successful and fruitful webinar. Thank you very much.
Many thanks, Michelle, for those introductory words setting the ground for today's webinar on life cycle sustainability assessment. My name is Stephen Usher, and I'm the Deputy Editor and ESG Manager at Aquamedia International, the publisher of the International Journal on Hydropower and Dams. I previously worked in environmental and social development roles for the Nam Turn 2 project, as well as for the United Nations, and most recently I've served on various ICOLD technical committees, so I'm very pleased to be moderating today. I do have an issue with my camera, so I will appear intermittently on and off, but we will get through that. As was made clear during the first webinar, which I hope you joined, and also just reiterated by Michelle there, sustainability is one of the most important topics influencing the support and opposition for dam construction worldwide. The first webinar was an excellent opportunity to present the main sustainability goals and objectives of the new ICOLD initiative. If you haven't already done so, I encourage you to follow the links from the ICOLD page to watch a recording of that webinar. Now, building on from that work, the group has now started to investigate the most appropriate tools and methodologies that can be applied to assess the sustainability of dams and reservoirs. Today's speakers will demystify some of these key tools and frameworks used for life cycle assessment and help to identify opportunities to ensure dam infrastructure continues to play a crucial role in the green energy transition, as well as to help mitigate some of the principal challenges of climate change. So just before I hand over to Luc and Francisco to run through the objectives and purpose of today in more detail, let me briefly just mention a few housekeeping messages. Firstly, we expect the webinar to again be fully interactive, and we encourage anyone with questions or comments to use the Q&A facility within Teams to post them. Hopefully, if you're on the browser or through the app, you can see a Q&A tab towards the top of your screen. So when posting any questions, please include the name of the speaker who you would like to answer the question, and also your own name and company or organisation affiliation. The format of the session is that speakers will each deliver their PowerPoint presentations. They have approximately 10 minutes each to do so, and there'll be a Q&A period to follow at the end once all speakers have finished. That said, please do post any questions at any point during the presentations, and a number of these will be selected to read out at the end. Okay, excellent. So without further ado, your first presenters today have been instrumental in driving the whole webinar process, as well as coordinating and drafting the content of the ongoing ICOLD research. So it gives me great pleasure to introduce Francisco Ortega and Luc Deroo. Francisco, as many of you will know as Paco, is an international specialist in the design and construction of concrete dams with more than 35 years experience. Since 1999, he has been running FOSCE Consulting Engineers based in Germany. He's a member of the Spanish and German National Committees on Large Dams and represents these two countries in the ICOLD Technical Committee P, dealing with cemented material dams. In addition to this, he's leading the preparation of the second volume on the sustainability of concrete dams within Technical Committee D of ICOLD. Luc Deroo is Chief Technical Officer of ISL, a French design and engineering company in the fields of dams, hydraulic infrastructure, energy, floods and drought management. His expertise covers dams and hydropower engineering, with experience in greenfield projects, safety assessment and structural upgrading. Luc is chairman of the ICOLD Committee on Prospective and New Challenges for Dams and Reservoirs. So thank you very much. Over to you two.
Thank you, Steve. Francisco and I have indeed prepared a brief introduction for today's webinar. This webinar is part of the Dams and Sustainability Initiative, as Michel said, which has two main objectives. The first is raise awareness about sustainability within our community, and the second, to gain a better understanding of what sustainability means in the context of dams and reservoirs. We aim to align our efforts with the UN Sustainable Development Goals, covering economic, environmental, and social aspects. Our approach will be, we hope, practical, with tangible impacts on design and construction, auditable, with quantitative metrics whenever possible, sensible, considering long-term and whole life cycle perspectives. This webinar is the second in a series of 4. The goal of this series of webinars is to provide content that will help define the steps towards developing our desired approach. As you can see on this slide, we are anticipating 2 additional sessions about greenhouse gases emissions accounting and also on how to account for other factors. Today's webinar is crucial, especially as we plan now to set up various working groups for the next steps. Webinar 2 builds on the findings of Webinar 1, of course. We have now 2 slides summarizing the main findings from the first webinar. First one is that we aim to be ambitious in our sustainability criteria, with reference to the planet boundary limits. This includes, of course, greenhouse gases emissions, but not only. also other quantitative parameters such as land conversion, and also non-quantitative or less quantitative aspects such as biodiversity and impact on social biodiversity impact and impact on social aspects. Key aspects of our approach includes considering the dam and reservoir as the relevant perimeter, not only the dam, also the reservoir. Analyzing long-term and whole life cycle impacts, 100 years and beyond. Defining metrics, that is indicators to reflect these criteria. Indicators are essential for developing this auditable approach. And we have some reflections on indicators now that we would be happy to discuss during this webinar. We think quantitative indicators are preferred, though we know that this might be difficult. Typical such metrics are illustrated on the slide now. We are thinking of options for fine-tuning these indicators to try to reflect the complexities of the issues at hand. These indicators will be used to compare options, and this will be especially important at the very beginning stages of a project when the options are still wide open. And we want to insist on that indicators will not replace environmental and social impact assessments, and they will not replace community involvement in the project discussions. Francisco, please.
Oh, thank you very much, Luc. Thank you to the audience. Thank you for joining us today. And thank you, of course, to all the speakers. I just want to very quickly summarize what we have now in front of us in this webinar. And we have a first presentation. Please look by Sonia Valdivia. This presentation is on the general introduction on LCSA and provides background and insights into the state-of-the-art assessment and recommendations on where to focus attention and how to proceed. The second presentation, we will learn the principles of life cycle thinking that are guiding funding institutions like the World Bank, and also the sustainability framework and what life cycle sustainability assessment tools are used at the World Bank. We also will listen about how the holistic LCSA leads to widely supported dam projects. The third presentation, we know that there is a great deal of work already done in the hydropower sector in relation to sustainability, and the Hydropower Sustainability Alliance has developed the Hydropower Sustainability Standard, which will be briefly outlined in this presentation. We are considering this precedent as a prime example to use in the life cycle assessment of dams and reservoirs ourselves. In this presentation, we will learn how the European Working Group on Sustainable Earthworks is organized and the status of the technical report that is being prepared on this topic, and some examples on GHG emissions and sustainability assessment are already included in and will be watched in this presentation. The next presentation focuses on the economic aspect of sustainability based on the published work dealing specifically, in this case, with dam projects. It also makes a very interesting link between the life cycle thinking and risk assessment. Based mainly in nuclear power plants in France, EDF has a long experience in the development of biodiversity footprint assessment, and this presentation shares this experience and shows illustrative results and references on how biodiversity can be assessed. It also warns of some difficulties when doing this. And the last presentation today will deal with social life cycle assessment inspired by a case study of a lithium mine in Chile. It describes possible methods and shows the application of an example scoring approach using various indicators, and concludes with some key messages applicable to dams and reservoirs. And with all that being said, we will now start with the presentations of the different speakers. Thank you very much.
Many thanks, Francisco and Luc, for those introductions of the topics that will be discussed today. So now let's jump into the first one of these, which will look, as Francisco just mentioned, be looking at LCSA through dam-specific lens. And to take us there, Sonia Valdivia is Scientific Director of the World Resources Forum, where she is working in the areas of sustainable recycling industries and life cycle sustainability. Sonia has an academic background in industrial engineering with a PhD in environmental management and policies from the Technical University of Karlsruhe in Germany. Sonia is co-author of many important publications, including various UNEP guidelines on life cycle assessment. So over to you, please, Sonia.
Thank you very much for the kind invitation and the opportunity to present to you some ideas, projects, work that we are conducting, in particular now in my last 10 years at the World Resources Forum Association, which is an organization that is very much in line with the work that you're doing. Our mission is to empower multi-stakeholder processes for innovation in sustainable resources management. And this is within planetary boundaries. I am very happy to hear same terms, same ideas coming from your previous presentations. We are based in Switzerland, and our focus is on materials. So minerals, metals, but now more and more on secondary resources covering plastics, textiles, to give you an example. So we pay a lot of attention on the principles of life cycle thinking. So our projects follow this idea, this basis. Circular economy is there, of course, and sustainability. So I'm not going to get into the details of the projects. If you would be interested, you can contact me later. We promote our work through a conference that is biannually organized, and this year we will have in Geneva the WRF 25 conference, where we will showcase our projects, results, but also of our partners. We work in consortiums. And at last, very important that I would like to highlight is as well that what we provide and produce aims to be a public good. That means that we make our tools, data, knowledge publicly available as public access reports, for example. So with this, I enter into the topic of life cycle sustainability assessment and the state of the art, the journey that we went through to get us to where we are now. After the evolution, of course, it's important to understand what it is, and also in the short time that we have, to try to explain some connections with the dams context. There are principles for life cycle sustainability assessment. What does it mean for the dams and reservoirs context? And some conclusions that hopefully can guide us to continue in this path of improving. So on where we are coming from, well, we could say not so long ago, depending on our ages, of course, but indeed, already since 1990, we see the emergence of a very important tool that is the multi-criteria decision analysis that considers the aspects of sustainability. That, I would say, would be the starting point. But it's not after the publication of the ISO standards that guide, that norm the way, the standardize the way to conduct life cycle assessment studies, where we can organize and be more practical and can streamline the application of life cycle thinking. And this in the area also of sustainability. So what we see here is a range of publications, key products, key recommendations that have been adopted by the community. That is an important aspect. That's why I'm highlighting them. They are considered the state of the art. So many studies that you will see will base on one or more of these sources that I am highlighting here. Of course, the SDGs that were published in 2015 are also super important because they give us the global framework, the global context for application, and we cannot disconnect from this. So on one hand, the publication of the ISO standard on 95, 96, plus the SDGs, and the latest publications on LCSA sustainability assessment with practical guidance and examples is what brings us today to the upscaling of this method. The role of stakeholders is important, a bit different or more prominent than in environmental LCA or life cycle costing or other approaches. Here, learning from the social LCA community, we understand that without identifying, addressing the concerns, the interests, the needs of the stakeholders, we cannot do a thorough and provide meaningful recommendations on life cycle sustainability assessment. So here we have the local communities, companies and investors and governance, to give an example. And their demands, their concerns, their questions are growing, are more important each time. So we receive questions from stakeholder groups that want us to dig in further on specific aspects that could mean impact. So we know from firsthand how important it is now and more to be in line with the regulations, to address also the consumers' concerns, and try to provide transparent and good results when informing customers about what we deliver to the market, what we produce. So, and with this, to focus on the dams and reservoirs, very, an illustration that summarizes the type of stakeholders that are concerned. So we have on one hand the social related stakeholders, environmental ones, institutional and financial. Institutional would lead or would be related, for example, to governance aspect, to give you an example. On the social part, typically what we have are the local communities, of course, but more prominently for this case, indigenous groups and farmers. Also the people living around these activities that could be small towns, for example. Other consumers of resources could be resources such as water, land are concerned as well. On the financial part, investors, owners of dams are relevant. I see that some of the speakers are very well connected. I mean, I have probably a lot to say on this aspect and would provide good examples. On the environmental aspect, more and more so the local governments, so municipalities of towns, to give you an example, but also the central government is concerned because activities are getting large, then more attention is given to this type of operations. And on the institutional side, the regulation is also doing more in order to address the specificities of these activities. Of course, this is still not equally addressed, but we see more and more these type of regulations at national levels. With this, we see that a holistic approach perspective is needed that covers not only the economic aspect, the safety perspective, but also the socioeconomic perspectives. In this regard, our proposal, the proposal of the community that have been working with for more than a decade, is about using the tools that already exist, very well accepted tools. Well, ones are younger than others, of course, which I will explain in a second, to use them and try to combine, to read the results, to understand the results in combination with each other. Sorry. Apologies, there is some construction suddenly. I will continue as far as I can. And with this, the idea is to get to the results of life cycle sustainability assessment on LCA, environmental life cycle costing, which will be addressed in the next presentations, and social LCA as well. The plus sign doesn't mean adding results, it means combining the results. The maturity levels are different because some have a longer tradition, more experience, more examples, more data as well. The methodologies are well developed, and data is, on the other hand, also an important aspect. And as you see, this gets a bit behind the methodological aspect. We can conclude on this slide that data exists and maturity is more advanced on the environmental side, and on the social side is less than on the other dimensions. On the databases, we have the EcoInvent that is very well known probably by many of you. And on the social related database, we have the S-LCA one and the social hotspot database. These are two key publications. If you give me 1 second, please, I'm going to.
Yes, we can hear you well, Sonia, no problem.
Now should be better. Hello?
Yes, yes, very good.
Thank you so much. So what does it mean applying this approach of having these 3 dimensions and using these ISO standards that exist for them, except for the costing part? What it means? It means being careful in, especially in the process of integration, when integrating the results. For example, when we have the social LCA, there we would have results related to fair working conditions, human and civil rights, well-being and dignity. And on the other hand, we would have results related to the environment on resource availability, water, for example, or ecosystem health. So the indicators related to these ones will be confronted one with each other. And in the assessment, the stakeholders, there would be a key moderating group that will facilitate the process of concluding and provide recommendations, should consider aspects such as ethical ones, cultural norms, political values, morality aspects, but also the common sense, experience, good judgment, intuition. So all this well justified, well grounded, with a good basis, with the context, but because it's not that a database will give you this information. We have to discuss, we have to assess this in the context of the community or society where this activity is taking place. So we will have results such as no-go issues, not acceptable ones, or ranking of aspects, or maybe trade-offs. This is also a very important aspect, and recommendations to be taken into account. We could have then in that way, for example, options such as dump type 1 and dump type 2, or not dump, where we could see on one hand on the environment, one option is better than the other or less good than the other. So it is up to the decision makers to make the decision in a responsible way. It could be a political issue. It could be a societal aspect where you have the participation of stakeholders for the consultation before making the decision. There are different processes depending on the case. And this will lead us to the final result of this assessment. And
please,
communicating,
Sonia, we are out of time now. If you could run a bit to the conclusions, which I think is very important for the audience. Thank you.
Okay, so you could see, we'll see this, the principles and examples in the slides that will be shared or in the video. Conclusions. LCSA is seen as a powerful tool for preventing unintended consequences. So before building, for example, a dam. But when applying this methodology, please define carefully the area of protection, that is the overarching area. Well-being is a typical area of protection to be considered, meaning the well-being of the societies, communities, but also workers, among others. positive impacts already exist, and they are called handprints. So they are worth highlighting, like job creation. The tailored framework is needed in this sector, and we foresee that moving from 40 social impact categories, that is what we have in social LCA, to 15, 10 to 15 is something that is plausible and recommended. And for dams in operation, a recommendation to conduct a social LCA, a life sustainability assessment, is important because time has passed, and this could add value to the still life operation of this dam. With this, I thank you for the time and happy to answer the questions at the end.
Thank you very much, Sonia, for sharing those insights. Yes, as a reminder, there will be time after the final presenter for questions. I encourage each of you to start posting there as we move forward via the Q&A tab, hopefully that you will see at the top of your Teams software. The next speaker is Nicholas Zmijewski, who is a senior environmental engineer at the World Bank, where he leads and advises on projects in natural resource management, hydropower development and environmental policy across East Africa. I believe he's currently in Uganda, so hopefully with a strong internet connection. Prior to joining the World Bank, Nicholas conducted research on water energy systems at the Royal Institute of Technology in Sweden. So over to you, please, Nicholas, if you're there. Nicholas, I'm not sure if you're... perfect.
All right. Can you see the slides?
Yes, yeah.
All right, thank you. I made turn off my video link preemptively, as we have a bit of a challenge at times with connection. Thank you for the previous speaker as well in introducing the topic. This helps very much set the stage for what I plan to run through, and I'll try to build on that as much as possible. I want to introduce the World Bank in specific terms, just to highlight that the objective, as stated currently, is to reduce poverty and promote sustainable development in its member countries. This is a relatively new amendment to reflect the emerging necessity to take these into account when planning large infrastructure investments. Moving to the next slide, the planning for these types of large-scale investments is guided by the tools applied, as well as the limitations of those tools. An optimized solution is determined by the constraints and the driving variables that are imposed on this system. So really, by considering the broader view of project influence, we can thereby have this larger and more comprehensive framework to consider the benefits and impacts of the proposed project. This then includes the benefits and impacts across the entire life cycle of the project, from preparation to decommissioning. As mentioned by the previous speaker, as methodologies improve and mature, this type of common understanding of how developing or in developing these proposals, how the tools can be improved and efficiently used to assess the project proposals and activities, but also which tools are most effective in certain situations. And I believe the next speaker will also speak to this issue. Looking at this from a practical point of view, LCA encourages planners to think beyond the immediate construction phase. We need to consider these broader project impacts, as well as the benefits from the project, as well as cumulative impacts of the project, considering planned initiatives for hydros or for dams. This would include other initiatives within the basin and the broader landscape. Dams are longer-term decadal initiatives for construction, but benefits and impacts are potentially multi-generational. The World Bank, as an institution, takes this longer-term perspective in its financing, considering both the potential issues during operation of the infrastructure as well as during constructions. For dams, this inherently requires us to review the immediate construction impacts with helpful metrics such as the one displayed here, benchmarking against other project characteristics. In this diagram, we can see megawatts as this relates to impacted hectares and PAPs within the project area. Now, these should be considered indicative metrics and be built on during the preparation of the project. But LCA also considers this longer-term impacts, and as we'll discuss later, I believe, on, say, for example, sediment management and downstream concerns, and bringing this broader perspective will incorporate those more complicated issues in managing the overall dam long term. So the World Bank applies the environmental and social framework, which requires which provides a blueprint for integrating sustainability across its investment project. It requires the integration of these elements at an early stage during project preparation, and importantly, the preparation of an environmental and social impact assessment. The ESF, as we term it, mandates that all environmental and social risks be addressed throughout the project life cycle, and not just during the initial inception stage. The ESF is a framework that includes 10 environmental and social standards, which cover across the gamut: labor, community health and safety, land acquisition, biodiversity, indigenous peoples, etc. For each providing sustainability criteria for dam projects, which we can discuss more in detail. A core principle of the ESF, as reflected in the first standard, is the mitigation hierarchy, where we work to avoid, minimize, reduce, mitigate, and compensate any adverse impacts. And this will be familiar for those who have worked with the performance standards, as well as the ESF takes a very, very similar approach. The World Bank requires that we have robust ESAs, and increasingly these include the LCA concepts. Specific examples may include the greenhouse gas emissions, but also cumulative impact assessments, e-flow assessments, and so on. As mentioned by the previous speaker, stakeholder engagement is indeed key. This is a vital element of project development, requiring meaningful consultations be implemented throughout the project lifetime. This being one of the key elements also to ensure benefits are shared and appreciated from the project over the long term. The bank does conduct during preparation a form of cost-benefit analysis and economic assessments that do incorporate life cycle costs, and these are overall longer term initiatives that the borrower also engages actively in. The Hydropower Sustainability Standard, which the next speaker will speak about, also helps with these exercises and has become an emerging initiative, also as a helpful tool for us as within the World Bank. So sustainability is baked in at an early conceptual stage. This starts with strategic options as to determine the best solution is actually selected. Importantly, an alternative assessment will need to be conducted, and these alternative assessments can then be judged through possibly a multi-criteria assessment or other tools that have been developed over recent years. During construction, there's also there needs to be a focus on implementing these planned mitigation measures and ensuring a high standard of delivery. The large construction of dams can indeed be disruptive, even in the short term. Ensuring that we have a robust ESMP is crucial to that effect, to ensure that we're minimizing the potential impacts. Once the dam is operational, sustainability efforts shift towards monitoring, management, and maximizing any positive impacts. Adaptive management is key here to ensure that should any negative impacts arise, that these are addressed at the earliest possible time. While many large dams are intended to last for generations, eventually a plan is needed for either decommissioning, repurposing, or rehabilitation. A life cycle assessment then needs to ensure that these possible long-term issues are managed in advance to avoid having them being legacy concerns. Sustainable sediment management is really key in planning in certain watersheds. Drafting a plan for sediment flushing, dredging, watershed conservation, or other measures to reduce erosion and sedimentation is really a key element of any dam construction at this point. We need to extend the life where possible, or have a plan to ensure the long-term sustainability. So from this brief description, a life cycle assessment is intended to bring in the most or the wider and broader implications of a project's design at an early stage. And but the World Bank standards can play a key role in addressing or meeting these sustainability requirements, using the accessible tools that are emerging and maturing over the next well, currently evolving as we'll hear about later. Investing in sustainability does yield long-term outcomes and aligns our projects with the global goals. We need to plan infrastructure investments that contribute to development, but not only in the short term. We need to consider the long-term effects and the broader impacts in the area. Thank you.
Okay, thank you, Nicholas, for those slides and for juggling your travel to be able to join today. Building on the sustainability criteria just reported, Kimberly Lyon will now overview the tools and methods of the Hydropower Sustainability Protocol. Just before introducing Kimberly, I know it's very challenging to try to condense so much work into only 10 minutes, but if each of the speakers could really try to keep to time so that we can still afford 25-30 minute or so Q&A session at the end, that would be fantastic. I appreciate your help on that. Kimberly Lyon is Senior Water Resources Management Specialist at the World Bank's Global Water Unit. She provides technical advisory support to projects across several regions and contributes to the creation and sharing of global knowledge on water storage, dam safety, and transboundary waters cooperation. Before joining the World Bank, Kimberly worked with the World Wildlife Fund and also the Ministry of Finance in Jamaica. So, Kimberly, the floor is yours.
Thank you very much. Thank you for the introduction and for the opportunity to share here today. Let me just get my slides up. Just confirm that you can see those. Good. All right.
Yes, thank you.
Good. So I should say that, the World Bank has been involved in the Hydropower Sustainability Standard for quite a long time. And we currently hold a position of chair for the Financial Institutions Chamber for the Standard. So that's the perspective that I'm coming to you with today. In the previous webinar, I gave a high-level introduction to the standard and the World Bank's experience with it, whereas today we will just very quickly recap the basics on what the standard is, and we'll spend more time on the assessment process and the performance requirements and the scoring methodology. So the Hydropower Sustainability Standard is a standard and certification system for hydropower projects. It measures their sustainability against a common set of criteria covering 12 ESG topics: ESG, environmental, social, and governance. And these topics are organized to be aligned with the World Bank's environmental and social framework and the IFC's performance standards, which Nicholas was just talking to you about. Projects that achieve a certain level of performance against the standard are eligible to be certified. These three project examples here illustrate that depending on the performance against the standard, they can be certified at the gold level, silver, or just certified. The standard also covers the project lifecycle from preparation to implementation to operation. For projects that achieve certification, the validity of the certificate will depend on the assessment stage. So preparation and implementation stage assessments are valid for 3 years, and the operation stage certificates are valid for 5 years. The certification process has 4 key steps. Step 1 is assessment. This is the biggest hurdle. So the accredited assessors assess the project against the standards criteria. Step 2 is publication, where the preliminary assessment report is submitted to the Secretariat to be published online. There's a period of public comment during which the Secretariat will also review and confirm that the assessment is in alignment with all of the processes for the certification scheme. If there are any comments, then the accredited assessors must respond to each one, and then they'll decide if they need to make any changes to the report. Step 3 is just application. So the project proponent applies to the Secretariat for certification. And then finally, if the project meets the minimum requirements for certification and all the process requirements have been confirmed as met, then the Secretariat will notify the governance committee that it intends to certify the project. If nobody objects and no concerns are raised, then the final report and the certification rating will be published online. And then we have a new certified project. All assessments are done by accredited assessors. This is very important. They have passed the accreditor training. They hold a valid license from the Hydropower Sustainability Council. They're professionals who are very experienced in the hydro sector. Many of them have auditor qualifications, and they've been specifically trained to deliver assessments with quality and uniformity. And so this is an important part of the quality assurance process. All 12 of the topics under the standard are organized into these sections. So assessment, management, compliance and conformance, and outcomes. The requirements on stakeholder engagement and support are also key, but they've been mostly bundled into topic number 10 on communication and consultation. We will see some actual text from a couple different topics later on, where we can see the breakdown of some of these requirements. So now let's dive into an example. We're going to use topic number 12 on climate change mitigation and resilience. So for the mitigation side of things, the assessment will look at the power density of the project first and foremost. And if it is above 5 watts per square meter, then we can move on. But if it's below this threshold, then the project will need to do a more detailed estimation of emissions intensity using the GRES tool or other site-specific calculations. And if the emissions intensity for the project is above the threshold of 100 grams of CO2 equivalent per kilowatt hour, then the project will need to have carried out a site-specific assessment to demonstrate that the project's GHG emissions are consistent with low carbon development. So this is the evidence barrier that has to be met on the mitigation side. On the resilience side, the assessors will also look for evidence that the project is resilient to the effects of climate change and contributes to climate adaptation. And this can come in the form of a resilience assessment based on plausible climate scenarios that considers dam safety, infrastructure resilience, environmental and social risks, power generation availability. The project must also fit with national or regional adaptation plans. And there's some guidance available on how to carry out these assessments. There is the Climate Resilience Guide put together by the IHA with support from the World Bank and others. And there's a new how-to guide that's coming out on climate change mitigation and resilience. So this is the actual text now of topic number 12 on climate change mitigation and resilience. So we start here with the requirements on assessment. We're not going to dive in line by line, but I just want to show you that you have a set of minimum requirements on the left, which correspond to international good practice. So these are the minimum requirements that have to be met. And then on the right, you have a set of advanced requirements. So this is really international best practice. And if you're going to achieve a higher level certification like silver or gold, then these are the criteria that also need to be met. For this topic, you can see that the requirements are almost identical across the different stages. So for the preparation stage, the text is almost exactly the same as the implementation stage and the operation stage. This is not necessarily the case for all the topics, it depends, but for this one, they're very similar. These are the management requirements. So for assessment, we were really looking to see that the assessment of the power density or the emissions intensity has been done So now these are the management requirements, and the focus here is on the mitigation plans, mitigation measures, what has been put in place. On the conformance and compliance, which is these at the top here, you can see that there are only requirements for projects at the implementation and operation stage for this particular topic. And then for outcomes, these are really focused on demonstrating that the project's emissions are consistent with low carbon generations and that the streams are resilient. So we want to make sure that everything that has been put into the plan or into the design is actually going to work, and what is the case for justifying that. So in looking at the topics, the accredited assessors will do a site inspection. They will review relevant documents. They will also carry out interviews with stakeholders until they're satisfied that they have sufficient evidence to determine if the requirements are met. Some issues are more clear-cut, like whether the project's power density is above the threshold, while other issues involve more assessor judgment, such as to what extent does the project fit with the national plans for climate mitigation. And this is why the accredited assessor training and accreditation process is so important. So there are some other topics that include more dimensions. So on the climate change and resilience, we had those two dimensions, mitigation and resilience. This topic on community impacts and infrastructure safety has many more dimensions, as you can see. Project affected communities, project benefits, infrastructure safety, public health. These are only the assessment requirements, so we still have the management, outcomes, and so on. Each one of these little paragraphs is a requirement that has to be met for the project to be considered as meeting the criteria. And so you can just imagine that for a topic like this, the site inspection and the stakeholder interviews are very, very important. A project must meet all the minimum requirements. So those are those on the left, the basic good practice requirements of the standard to achieve certification. If a project wants to achieve a higher level certification, then it must meet at least 30% of the advanced requirements for each topic to get silver, and at least 60% of the advanced requirements to get gold. So this scoring diagram is for the Ituango Hydro project in Colombia. So you can see here, this first bar, it passed the bar on all the minimum requirements to meet the certification requirements. It didn't quite make gold because it didn't achieve 60% of the advanced requirements on biodiversity and invasive species. So this project was certified silver. So just very quickly, I think the main question for us coming out of this initiative regards to the standard is how will this working group want to use the Hydropower Sustainability Standard going forward? There is a potential opportunity, I think, that is worth noting here, which is that at the next governance meeting of the standard, there will be a discussion on the possibility of adapting the standard for non-powered dams. So right now it is just focused on hydropower. So I think the timing here is good to be thinking about these potential synergies. And so that's my presentation. So thank you very much. If you would like more information, you can go to the Hydropower Sustainability Alliance website, or you can also reach out to me or to the HSA. I've included the name of the Executive Director, Joao Costa, and he'd be happy to receive any questions or follow-up discussions through their email, which is right here. Thank you.
Thank you very much, Kimberly, for your overview of the Hydropower Sustainability Standard. Jean-Pierre Magnan is now going to look at other sustainability frameworks and principally in their application to earthworks. Professor Jean-Pierre Magnan is the steering committee member of the International Society for Intelligent Construction and head of Geotechnical Engineering, Environmental and Risk Department of the French Institute of Science and Technology for Transport Deployment and Networks. Jean-Pierre is involved in research, teaching and consulting in the fields of geotechnical engineering with more than 300 technical papers published to date. So over to you, please, Jean-Pierre.
Well, I will make you a short presentation of experience gained about questions of sustainability in a particular field of civil engineering, which is called earthworks. Earthworks is the construction of earth structures, which can be all various types of things, including embankments, dikes, etc. So this work was done within a technical committee of the CEN, that is Organization for Standardization in Europe. And this committee has drawn different standards and is now working on a technical report about sustainable earthworks. And this work began in 2021 and is expected to finish end of this year. That is 4 years later. This working group was created in order to discuss relationships between earthworks and the environment, and the name was later changed to Sustainable Earthworks. And this report includes different chapters. The first one is about the limitation of greenhouse gases production. There is a chapter about preservation of biodiversity, one about quality of water and limitation of use, one about preservation of topsoils, then economy of natural resources, increase of resilience of earth structures, limitation of impacts during construction, methods for comparing options in an earthwork project, example of existing practices, and a conclusion which was named Ways Towards More Sustainable Earthworks. And all this is related to climate change. I was asked to give ideas of how such a work has been organized. So in our case, we have divided the whole task into chapters, and each chapter aims at answering one series of questions. The first series is linked to the production of greenhouse gases. The second, the following ones are devoted to preservation of water, fauna, flora, and topsoil. Then there is a chapter about the use of quality of preservation of quality soils and rocks. Then limit the impacts of works during construction and create long-lasting structures, account for climate changes. But all these environmental questions have to be answered with respect to existing laws, standards, and other good practice rules. Our working group is organized like all groups within multinational organizations. The working group members are chosen by member countries, and there is a convener, which is me, and the secretary. In this particular case, 6 countries participate: France, Germany, Ireland, Spain, Sweden, United Kingdom. About 20% were involved, and we made up 9 task groups at the very beginning, 1 per chapter, with members from different countries. And the task groups write texts which are discussed at the working group level, and finally they will be discussed at the technical committee level, and then there will be a vote at the CEN level. What are the typical difficulties we met when doing this work, and what solutions were chosen? In fact, the First problem is that different experiences and practices exist in different countries, and individuals, authors, reflect instinctively their national experience. And besides, since all countries have not similar contributions, references are unequal, but we had to accept that. And all members are encouraged to give additional information to each chapter. Experience from my side that managing a group of experienced specialists is sometimes difficult. And we usually need patience and psychology. And another problem is that since this is not full-time work and with volunteers, scheduled works are not always done between the meetings. And once again, patience is needed when you try to convene such activities. I took only 2 examples from our report, but the report will be more than 100 pages dense text, and there are many other information to take from it, and it will be probably available by the end of this year. The first example is discussion about the reduction of greenhouse gas production. In earthworks, the main sources of greenhouse gases are the fuel used for earth-moving machinery. It's the second main source is the production of greenhouse gases linked to imported materials, which may be aggregates, geotextile, lime, or hydraulic binders. And the third one, which is less well evaluated, is the excavation of topsoil and organic materials, which releases embodied carbon. 2 types of action were described. The first one is the reduction of each source of greenhouse gas. First, there is important action on vehicle fleet and equipment. And the second action is to try to use low carbon materials and improve the production of lime and hydraulic binders. Next to this, we felt the need to not to depend only on the production of greenhouse gases, because benefits may be gained by using techniques which produce greenhouse gases, but give much large benefits from other points of view. And we tried to explain that it's now better to evaluate efficiency of techniques at the whole project level rather than on each task. The second example is related to the way sustainability may be assessed. When we began, it was 4 years ago, there were not so many actions taken for works. There are many standards about products and some industrial activities, not on earthworks. And we had to cover and to find out what could be used to make the assessment of sustainability. In fact, various tools may be used for this. And what is important is to include environmental, social, and economic aspects. The life cycle assessment is a tool which enables to evaluate environmental impacts throughout the life of a product, but complex questions arise. The first one is, what is the product in the case of earthworks? Is it a fill, Is it the field plus an infrastructure, such a railway or a road? Is it the same only during construction, or should we include traffic, which completely changes the evaluation of greenhouse gases? So this is the first important question. The second one, what is the end of life in the case of a road? Because it's difficult to predict what a road will be. What experience from hundreds of years is roads never disappear. They always exist. They may be modified, but they always exist, and public land is never sent back to private property. So the problem is, how can we make predictions about the future of enough earthwork, of enough structures? And the question was raised of whether we should end comparisons at the end of construction for earthworks, because it's something which can be well defined, or should we include the use of the structures for years, and what means deconstruction in this particular case? The difficulty associated with carbon footprint assessment is that it focuses on greenhouse gases and neglects other beneficial aspects of the project. For example, when treating local soil found locally, it's not more necessary to bring other materials like aggregates from far away. So we are decreasing the importance of transportation. But we have to pay by producing some more greenhouse gases. So our tendency and what we try to explain is that sustainability assessments should be better based on multiple indicators. And in the report, but we were copying things which we found in different standards. There are 4 groups of indicators. There is environmental indicators, such as the emission of greenhouse gas, measured as a CO2 equivalent, emission of acid gases in sulfur O2 equivalent, the consumption of energy resources, the consumption of mineral resources, the consumption of water, the pollution of water, the loss of agricultural and forest areas. There are social indicators, such as the exposure of residents and workers to nuisances, road safety. There are economic indicators like the creation of jobs, the use of local companies, the construction costs, damages to local road network. And there are other global indicators such as the production of waste, the use of excavated material, reused on site, and the volume of recycled material from anywhere used on the project. This is the tendency we have, that we are going in this direction, trying to say that there are many possible indicators that should be considered, but the choice is in the hand of the buyer or the client or the administration or whatever, the people who decide, because there are no predefined relationships between these indicators and the decision. So it's still a matter of choice for the owner or the people in charge of taking decisions. So this is the end of my short presentation.
Thank you very much, Jean-Pierre, for sharing those useful insights. As a reminder, there'll be time after the final presenter for questions, and I see delegates are starting to post these already through the Q&A tool, which is great to see. hopefully you see the Q&A tool, so not the chat, but there should be a specific Q&A logo at the top of your screen. The next step in our talks today will focus on costs and specifically the life cycle cost assessment of dams. To speak on this topic, I'd like to introduce Dr. Alena Raymond. Alena is a civil and environmental engineer with expertise in life cycle assessment, sustainability, and geotechnical engineering. She obtained a PhD for her research focused on developing an LCA methodology to evaluate the sustainability impacts of emerging geotechnologies. And as the lead LCA practitioner at AmSpec, Alena supports LCA projects across multiple sectors. So over to you, please, Alena.
Thank you very much. Can you hear me and see my screen?
Yes, loud and clear. Perfect.
Okay, great. So hello, everyone. Today I'll be speaking about life cycle cost assessment of dams. I'll start with some introduction and background on life cycle cost analysis, or LCCA. I'll next walk through 3 examples of LCCA in dam engineering. Then I'll briefly talk about how we might be able to incorporate life cycle assessment and life cycle cost analysis into risk assessment for dams. And finally, I'll wrap up with some conclusion points. The dam safety community recognizes the problems and challenges associated with aging infrastructure and has developed strategies to analyze existing facilities, assess risk, and develop risk reduction measures. However, there has not yet been a conscious effort to consider the sustainability of alternative actions. So environmental life cycle assessment and life cycle cost analysis are existing tools that can assess environmental and economic sustainability and inform asset management decisions. When applied to dams, these tools can help identify the least cost or least impact alternative over the life cycle of the asset. So where environmental life cycle assessment, or LCA, is a standardized framework for evaluating the environmental impacts of a product or system, considering the entire supply chain and life cycle assessment from cradle to grave, life cycle cost analysis, or LCCA, is an equivalent economic framework for evaluating the costs over the service life of a constructed asset, from construction or acquisition through operation and maintenance, and eventually to end of life or disposal. LCCA can be employed to compare competing products or systems by weighing their financial trade-offs while avoiding burden shifting to other life cycle stages, regions, stakeholders, or generations. And there are international and national standards for LCCA for constructed assets. These include the ISO 15686-5 standard, as well as ASTM E917-17. So now I'm going to be walking through 3 brief examples, and example 1 is focused on employing lifecycle methods through lifecycle planning. So a study in 2018 forecasted the potential lifecycle carbon dioxide emissions of 4 newly constructed earthen embankment dams over a 100-year time horizon. And lifecycle costs could be similarly projected to visualize how costs accumulate over the lifecycle of the asset. This study found that the impacts and costs of planned repairs can be significant over the dam lifecycle. And these kinds of LCA and LCCA results can assist dam owners in setting priorities, deciding on timing of action, and identifying sustainable interventions. Example 2 is focused on alternatives assessment. So as demand for renewable energy increases, retrofitting of existing non-powered dams for hydropower will likely become more common. And a study in 2020 compared the life cycle impacts and costs of alternative options for modifying an existing dam to generate hydroelectricity. The independent and alternative retrofit options included modification of the embankment, the scour gates, or the spillway. And despite having larger impacts and costs, the embankment option was ultimately selected because it posed the lowest risk to dam safety. So this study demonstrates that trade-offs sometimes exist between hydroelectric capacity, dam safety, environmental impact, and cost. And while life safety must take precedence, tools like LCA and LCSA may be used in asset lifecycle planning to inform decisions that result in more sustainable infrastructure solutions. This third example is focused on strategic portfolio management through lifecycle cost analysis. And though still uncommon, owners of dam portfolios have begun to consider the lifecycle costs of their assets to help prioritize investment decisions and dam safety activities. In 2018, the city of Missoula in Montana used LCSA to evaluate available management options for 10 of their dams that provide emergency backup water supply for the community. Using the life cycle cost analysis results, 4 of their dams were identified as good candidates for rehabilitation because they have the largest storage capacities and the lowest cost per acre foot to rehabilitate. 4 dams were also identified as the top candidates for decommissioning, either because of dam safety concerns or because they have smaller storage capacities and low decommissioning costs. The last 2 dams in the portfolio were also recommended for decommissioning because it was the least cost decision, and doing nothing would mean that the dams would be out of compliance with dam safety regulations. So this example illustrates how LCSA can be utilized at the portfolio level to inform asset management decisions that efficiently leverage limited resources and maximize long-term sustainability. Shifting gears, on these next 2 slides, I'm going to illustrate how lifecycle-based methods can be integrated into the risk-informed decision-making framework to identify risk reduction measures that reduce risk as low as reasonably practicable. This ALARP principle aims to balance the costs and benefits of risk reduction and could be further enhanced by implementing a life cycle perspective. So this is a hypothetical example that compares alternative risk reduction measures for an existing dam. The plot in the middle of the screen is an FN chart, where F is the estimated annual failure probability and N is the estimated life loss. So this plot shows the current total risk for the dam as is without modifications versus the risk levels for the dam were risk reduction measures 1 through 5 to be implemented. Each of these 5 risk reduction measures reduces risk below acceptable levels. However, we need a way of ranking or prioritizing these alternative risk reduction measures, and I propose using life cycle methods to do this. So this plot on the right hand of the screen, here I'm showing the annual average annual life loss, which is F times N, versus life cycle impact. Or similarly, we could consider life cycle cost in dollars. And from this plot, we can see that risk reduction measures number 4, 5, and 1 constitute what we call an efficient set of solutions that minimize average annual life loss for a given life cycle impact and also minimize life cycle impact for a given average annual life loss. Conversely, risk reduction measures number 2 and number 3 are inefficient solutions and should not be selected, since there are other risk reduction measures that reduce risk at lower life cycle impact. Now, there are many other factors in play during the decision-making process that influence the selection of risk reduction measures like scheduling and permitting. However, this example demonstrates how life cycle methods and life cycle thinking could be incorporated explicitly into the risk-informed decision-making framework. So to conclude, rehabilitation of deficient and deteriorating dams is critical and will require substantial resources. Tools like life cycle assessment and life cycle cost analysis identify environmental impact reductions and cost savings opportunities and lead to better environmental, social, and financial outcomes. And this concept of life cycle thinking and the application of life cycle tools play an important role in the development of sustainable infrastructure solutions and can address challenges related to climate change, global energy demand, and depletion of natural resources. So with that, I'd like to thank you for your time and attention, and also recognize my colleagues who work at Geosyntec who contributed to the material I presented today. So thank you very much, and I'm happy to take any questions later on.
Thank you very much, Alena, for sharing those insights on the cost aspect. We'll now take a look at biodiversity with case studies presented by Bonaventure Fontanier. Bonaventure works at Electricité de France as part of the engineering centre in charge of environmental risk assessments and surveillance for the French nuclear fleet. His work includes the application of biodiversity footprint methodologies as well as implementing science-based targets. So please, over to you, Bonaventure.
Thank you. I'm just going to share my screen. Okay. So, hi everyone. So my name is Bonaventure Fontanier, and I am from EDF. And I'm here to introduce you to biodiversity footprint and life cycle assessment through a case study we conducted on our nuclear facilities. So I'm part of an engineering center in charge of environmental risks assessment and surveillance for the French nuclear fleet. And while nuclear and hydropower facilities differ, of course, I think there's a lot to be learned from the respective approaches in the two sectors. So I hope it will be interesting for you. By the way, my colleagues from the hydraulic department, I think, are giving a speech in another webinar, so you may have a look at it if you want to go deeper into the subject. I will start by explaining why we work at EDF on biodiversity, and then I will focus on one method we used. And as the subject is very vast, I will just give a very general idea, but I will be also happy to answer your questions during the Q&A. So a few words about Electricité de France first. It is a French company that operates worldwide with around 23 gigawatts of installed hydraulic capacity. This includes run-of-river facilities and also dams, pump storage, and tidal. So why is biodiversity so important to us? First, this topic is not new because EDF has a more than 40 years old year-long expertise in this field, and we are concerned because we own and operate industrial facilities, of course, and they interact in different ways with the environment, and many are located near specific areas, such as protected areas in France and internationally. We also have a lot of data due to our regular monitoring, and we implement the mitigation strategy, avoid, minimize, compensate in our projects. And last, reporting frameworks and regulations, such as the Corporate Sustainability Reporting Directive in Europe, are evolving, and with more requirements on biodiversity, while I think climate was a core topic of these frameworks until recently. There's no common definition of biodiversity footprint, but one way I found to define it is given by the IAEP, that is the impact of commodity, company, person, or community on global biodiversity measured in terms of biodiversity change. Actually, this is quite a broad definition, that encompasses a variety of needs and methods. Regarding the applications of these tools, you could have, I just give some examples, the comprehensive assessment of the impacts of your activity or your company, according to the 5 main drivers of biodiversity loss as identified by the IPBES, that are land use change, water use, climate change, pollutions, invasive species. Also identifying the hotspots through the value chain and ways to reduce their contributions. Also support decision-making and biodiversity-related targets and other. There are many existing tools and methods that can be included in biodiversity footprint landscape, and they have different maturity levels. Some of them are mature for specific applications, and others are still in development. This table that you're seeing is from Laurent et al. And gives an interesting overview of the tools, as well as their potential application. So for example, you have the assessment of current impacts of your activity, tracking progress towards targets, or comparing design options for a project, for example, and the scope of applications, for example, a product or a service. It could be the production of 1 kWh, the site, the supply chain, or at corporate level, and more broadly at portfolio level also. And in the same report, you will also find guidances to select the most appropriate approaches according to your needs and available resources. In our case, we tested 2 methods that are the Global Biodiversity Score, GBS, developed by CDC Biodiversity, and the Product Biodiversity Footprint, PBF, developed mainly by iCare. And in this presentation, I will focus on the PBF as it is LCA-based method. Some of the key input data of the study was the pre-existing life cycle model and assessment realized by EDF R&D in 2021. And this represented a considerable amount of work preliminary to the biodiversity footprint study. Generally speaking, data collection and pre-processing is a very laborious stage in this kind of work. And there are, however, a number of tools that can make the job easier. For example, databases such as EcoEvent may provide default data and models if needed. And some other tools, such as this GBS, use XIBAS, which is a multi-regional input-output model that could provide information on your value chain too. The PBF, so the Product Biodiversity Footprint, consists in 3 modules that allow to refine and complement the assessment. The first module, that is M1, uses the LCA inventory and applies the characterization factors of LCA impact, which is the main underlying LCA model of the PBF. Next, with M2, you may adjust the impact with site data and other characterization factors from the literature adapted to your needs. For example, in this module, you can use input data on specific land use practices and management, such as zero phyto policy if you have one. And eventually, the third module can provide a qualitative or semi-quantitative complementary assessment, in particular for impact categories that are not yet covered by LCA method, such as management of species and invasive alien species. And the results will not necessarily be comparable to those from the previous modules, but I think it brings interesting additional information. Just to give an idea of what results can look like. So the PBF expresses the impacts in PDF year, that is potential disappeared fraction of species multiplied by years. So it's a bit complex, but it can be rewarded as the equivalent loss of species within a year. This unit, as is very often the case with biodiversity footprint tools and methods, is quite hard to understand, for me at least, to handle and a fortiori to communicate on. So in this study, we decided to compare the impact of one facility in a spider-like diagram so as to visualize the contribution of the different impact categories. So you may have around 10 in 3 scenarios at different time, 2013, 2019, and 2024. Different actions can explain the reduction of the overall footprint you see through the years. For example, reducing chemical and thermal discharges. You can also have a positive contribution to biodiversity that correspond to the negative percentages on the diagram. For example, by implementing positive action, such as restoring damaged natural habitats. I think it's important to know that if you conduct your own test, the presentations will certainly be different, whether in terms of impact categories you will choose to focus on, of diagram type. Here it's a spider-like diagram, but you could have absolute values in PDF here with bars, for example, or goals. We choose to compare scenarios, but as said before, you can have other type of applications. So even if this type of picture, I think is useful to get an idea of what it looks like, there's more to it. This method provides very interesting information that complement what we already do and know at site level. And also you may find a variety of applications according to your needs and resources. Literature struggles to cover all the tools and methods. There are many of them, and they are constantly evolving. There is one aspect not to be overlooked, I think, it's the ability of tools to adapt to your processes and activities, for example, in a co-construction approach with the developers of the tools. For example, to complete the scope of the tools with pressures that are relevant to your business but not yet covered. There are also significant limits to these methods. I will not detail each of them, but overall, I think that one must take great care when using them and when interpreting the results. Today, I'm not sure that most tools are fully mature. I think that it's important for potential users, including companies, scientific community, institutions, to test them and to share the experience, because this can contribute to the overall development of the methods. And eventually, for those interested in delving deeper into the subject, you can find a lot of information online. I can recommend the reports edited by the European Biodiversity and Business and Biodiversity platform that provides the most comprehensive, I think, assessment of biodiversity footprint approaches, 37 biodiversity measurement approaches in the last report in 2024, and some information also on my colleagues' works from EDF Hydro on adapting the product biodiversity footprint, the PBF, to the process and to extend the coverage of the tool to aquatic biodiversity. That's all, so thank you. I hope this presentation has sparked your interest on biodiversity footprint methods. And of course, don't hesitate to ask for questions during the Q&A. Thank you.
Thank you very much, Bonaventure, for sharing that analysis. Some of the documents referenced by the speakers today, we hope to compile a single list which you'll be able to access after the meeting via the ICOLD website. There will be a short report published in the International Journal on Hydropower and Dams, which will appear there, as well as a full recording of this webinar and also the webinar we had earlier last year. Our final presenter, before we move to questions, is Isabel Wolf, Chair of Sustainable Engineering at the Technical University of Berlin in Germany. Isabel has previously worked as the Siemens Research and Innovation Ecosystem Manager, where she served at the interface between university researchers, startups, and researchers from industry. So please, Isabel, if you could share your screen.
Yes, hello everybody, and also from my side, thanks for the opportunity to present a very interesting topic to you. Sharing my presentation. All right, is it all good like this? Can you see the presentation mode?
Yes, all clear, yeah.
Fine.
Okay, all right. Yes, I have brought social life cycle assessment methodology with me today that I will explain to you based on a practical example. I want to start with why we are using S-LCA. we live in a globalized world where corporate supply chains are becoming more and more complex, and with that come societal challenges like child labor, poor working conditions, human rights violations along these supply chains. And companies want to take responsibility not just for their direct operations at site, but also for the social risks throughout their supply chains. So S-LCA is a tool that can assess both positive and negative performance across the whole value chain, and it can identify hotspots and thus support several processes, such as decision-making, policy development, or corporate sustainability reporting. And finally, as we already heard in Sonia's presentation, S-LCA is required to complement the third pillar of the lifecycle sustainability assessment. The key S-LCA guidance comes from the UNEP-ZETAC task force. I just want to make sure that you have seen these documents because they are very helpful if you want to understand how S-LCA works. So first we have the guidelines for S-LCA of products and organizations. Then we have the methodological sheets and the pilot projects, which are showcasing practical case studies. These documents were developed by international experts from academia, industry, and policy, and also our chair contributed. So it's quite nice that they are now widely applied across various sectors. Also worth noting on the side is that based on these activities, there was the first ISO standard for S-LCA published in October last year. Okay, the S-LCA guidelines follow the framework also used in environmental LCAs. So they consist of 4 iterative stages, which means that the process is not strictly linear, but cyclical and adaptable. And today we will do a sprint through these 4 phases based on a practical example. I'd like to share a case study by my colleague Lindsay Roach with you, who conducted an S-LCA on lithium mining in Chile, focusing on potential impacts on water resources and local communities. So the mining company SQM, which specializes in the production of lithium and its derivatives, commissioned this study, and they produce in the Salar de Atacama in Chile. This area is home to several indigenous communities that have inhabited this area for 11,000 years by now. And in scientific literature, there are many studies on hydrogeology in this area. And there are also ethnographic studies on the indigenous communities. But to consider the perspective of all relevant stakeholders and the hydrological considerations in one assessment was not yet done. So that is why SCL here was a suitable method, and its application was a novel contribution. So let's start with the first phase of an S-LCA, the goal and scope definition. The goal of the study was to assess the potential social impacts of lithium production on the surrounding local communities. And the scope of the study is cradle to gate, meaning from brine extraction through following chemical refinements in a chemical plant. The next step is the lifecycle inventory phase, where the data is collected and validated. And this is by far the most time-consuming phase in social lifecycle assessment. The data for this project was provided by the company SQM. It included certification materials, HR data, sustainability reports, but my colleagues also conducted site visits to the production facilities and visited the community projects. And they also did 2 rounds of interviews with the local community members to collect primary data, which is rare and very valuable in S-LCA. The third step is the impact assessment. And here is where it's a little bit different to the environmental LCA. because we, in theory, can apply two different methods here. Firstly, on the left side, the reference scale approach, which is still a young approach, but already commonly used in many case studies. And then the second approach is the impact pathway approach here on the right side, which is evolving, but rather still research. And we will focus on the reference scale approach now because it was also applied in this project. So reference scales are typically comprised of 5 levels, where each position on the reference scale is a performance reference point. So 0 is compliance, +2 is the best performance, and -2 the worst. Reference scales are developed by selecting performance indicators for each position on the scale. And these performance indicators are thresholds or targets that set different levels of social performance or social risk. They can be qualitative, but also quantitative, and they are based on international standards, local legislation, or industry best practices. So here's an example of a reference scale from the case study for the stakeholder group local community and their subcategory access to material resources, namely water. So there are in total 7 performance indicators in the background of this reference scale. And as you can see in the middle, the compliance level requires the fulfillment of the performance indicators 1, 2, 3, and 7 here in yellow. The company scores the best performance when they fulfill all the performance indicators, and worst if none are fulfilled. This is a list of these underlying performance indicators. So again, if we want to reach the compliance level 0, the company has to fulfill the first 3 basic indicators on policies and water reduction intentions, but also indicator number 7, meaning that there are no raised concern about negative effects on freshwater resources. The reference scales in this way are developed for all relevant stakeholders and their subcategories, and there are different scoring methods to assess a company's performance against these indicators. So here are the overall results for each local community subcategory. We, in this project, applied a precautionary approach and an average weighting approach to identify potential hotspots and also to compare. And the differences in these scores, which you can see with the color codes, especially in cases of poor performance, highlight how sensitive the reference scale method is to the chosen scoring approach. So coming very quickly to the 4th phase, which is interpretation. Here we have to complete many different checks, and the discussions in this phase form the basis for conclusions and recommendations. So due to the limited time today, I want to highlight 2 social hotspots and the recommendations to SQM. So first, access to freshwater was a hotspot, meaning that the community concerns included brine over-extraction and the lack of clear information on generally water topics. So in response, SQM should improve the transparency for water-related topics and communicate more actively with affected communities. And then the second hotspot is respect for indigenous rights. Many community members felt that consent was not properly obtained. This has led to a lasting sense of cultural disrespect, and recommended that SQM should ensure that their programs reach all indigenous groups and that they maintain a respectful, consistent dialogue. So some takeaways from the dams for the dams community. So like in lithium mining, dams and their reservoirs impact local communities through land use resettlements or ecosystem changes. But of course, there are also significant social benefits. So it is important to assess both positive and the negative impacts in an assessment. And to understand these, we need to consider different stakeholder perspective. And this is where S-LCA can help, because it is a structured way to assess both risks and benefits across multiple life cycle stages and across multiple stakeholder groups. And with that, thanks for your attention. And yeah, if you want to continue a conversation, I'm happy to answer questions, but you can also reach out via mail. Thank you.
Thank you, Isabel, and thank you to each of the speakers for their excellent contributions today. We are a little behind schedule, but we have 10 minutes or so to take some questions. And if there are any particular points that you, the delegates, would like to focus on, please do post them through the Q&A icon at the top of your screen. The first question I have is for Sonia, a question posted by Garcia Ruth. And the question is, could you please comment on the availability and content of social databases and whether these are open access or paid for services?
So thank you for the question. So yeah, this is a very good one. Databases are not for free. There are annual fees for these tools. And I think also on social LCA, because that was a specific point, no specific data is available, more generic data, country data, or sectoral ones. So this is mainly to understand the general hotspots, but not to conclude with final results.
Okay, very good. Alena, a question for you, please, from Malcolm Barker. Asks if you may clarify how LCA and LCCA were used in the risk assessment plots that you presented in your presentation. Perhaps you could pull up that slide if possible.
Yes, I will. So the life cycle methods were used explicitly in developing this second plot, where we have a measure of risk against life cycle impact, or also, but not shown, life cycle cost. And so life cycle impact and cost were used as a way of ranking or prioritizing these alternative risk reduction measures and selecting ones that, that minimize life cycle impact and cost while also minimizing risk and, maximizing dam safety. So there's some trade-offs here that, you need stakeholder engagement to decide just how low, acceptable risk needs to go. But that's shown by the dashed line, and two measures that were previously considered before using this kind of ranking and prioritizing scheme were thrown out as not optimal or not efficient. I hope that answers the question.
Okay, very good. Yeah, I think so. And Malcolm, the slides will be made available through the ICOLD website, so you'll be able to go back and look at these and peruse them in more time at your leisure. Isabel, a question for you, if I may. A question actually which comes up often throughout not just the series, but also the work in the Sustainability Committee of ICOLD. What was the company's motivation to conduct the analysis? Was that financial, for example, reputational, legal? What was the driving force to undertake the work?
So they really had an interest on why there were conflicts rising all the time, because they were actually doing good efforts in environmental context to minimize their impacts, to stay below all the thresholds that they were given, but still the local communities raised concerns, and they were simply unable to understand how this can happen. And that's why they in one bundle conducted an environmental LCA with us, and in parallel the S-LCA, to see how this is can be merged together, or if this is like a full picture. And they realized that the main problem is that they had different worldviews on the resource brine, and they were not aware of that. And that's, yeah, why it was super interesting for them to, so to see these results in the end.
Great. So it was self-initiated. Is that correct?
Yeah.
Yeah, very good. Okay, another question here to Nicholas. I hope you're still with us, Nicholas. I hope your connection is holding up. The question from Pablito is, for dam projects aimed at economic growth, how do we balance the environmental and social goals of the ESF with respect to the development needs of recipient countries? So I suppose the trade-off of getting a project done to making it perfect. Are you there, Nicholas? I know you were traveling, so perhaps it would seem not. Okay, in that case, Jean-Pierre, could you please explain and expand on how it might be possible to combine the indicators which you listed in your presentation to get a global assessment? And I think, Isabel, you touched on the same idea of the inherent challenge of non-commensurability when you have different factors, different measures, whether or not you can combine them, whether it's an environmental with an economic factor, or in fact two environmental factors side by side, biodiversity, for example, alongside, I don't know, habitat loss. So Jean-Pierre, if you had any thoughts to share on that, that would be great. Thank you.
In fact, this is one of the subjects on which we could not come to definite conclusions. That is, we kept the solution open and unknown, with only a list of possible factors and to be accounted for, but the way they are have to be combined, and the proportion of the importance to give to each of them was not clear, because in fact, in our view of the problem, the situation may be so different that we cannot have one rule. And this is the reason why the choice between the combinations of the different indicators was given to the client or the owner.
Yeah. Okay. So yeah, that's interesting. So it's one of these problems which is hard to resolve. I think one of the presenters brought up the multi-criteria decision analysis, which was kind of the starting block for this sort of analysis, and which identifies the difficulties in combining divergent factors where they just can't be combined. There's you can't trade them off easily. Bonaventure, perhaps you could jump in and answer and discuss, are the current biodiversity footprint methods sufficient, in your opinion, to manage a project's impact on biodiversity, or do you think there's further refinement and learning required?
Well, I think that they can help in part, for example, to identify hotspots of impact, but they are not mature to set, for example, and monitor progress targets if you want to set one according to a project, or, for example, to conduct the mitigation approach, avoid, minimize, and compensate. We wanted also type of data, for example, through inventories. So I think there are plenty other approach to consider to fully manage biodiversity in a project.
Mm-hmm. Okay. Another question here from a delegate. It's actually addressed to any speaker, so please feel free, if you feel you can answer this one, to jump on. Do you see links between LCSA for dams and topics such as the resilience towards natural hazards, including earthquakes, flash floods, landslides, etc., or human-made hazards, since both of these need to be dealt with in the design phase of a project? So can you see any overlap, or any linkages between the LCSA approach? Is there anyone willing to?
If I can then try make a try. So, of course, we see the linkages, especially if we consider the holistic perspective, the sustainability perspective, because this is not a short term, it's a mid-long-term perspective where we need to be carefully watch out the planetary boundaries aspects. And on this, we have activities that are also natural ones, natural phenomena. So all this is in place, should be in place. So this is really a very good question. Actually, I like it very much. And of course, we agree, we have to be humble. We still need to work on the modeling, on data, on how to integrate all the elements. But this is precisely we were heading to with this approach.
Yeah. Okay. I'm very sorry, but we are very.
I think Steve, Michelle wanted to say something quickly.
Sure, Michelle, if you could.
Thank you very much, and very quickly, it's related to the last question and answer. In my view, sustainability and dam safety or natural hazard are completely related. And dam safety is the primary, in the case of dam, primary condition of sustainability. Even for one structure, if it fails, it's not sustainable. And more generally for our profession. Ituango has been mentioned in one of the presentation. As you know, Ituango was in a very serious condition during construction, and probably if Ituango had failed, I think that our profession would be in a very difficult position now, and sustainability of dams will be posed in different way. So I completely agree with this connection between natural hazard, dam safety, and sustainability. Thank you.
Thank you, Michelle. So, yeah, dam safety and sustainability, inseparable objectives and inseparable to each other. So I'd just like to take this opportunity to thank each of the speakers for their time and preparation today, as well as our delegates joining from around the world to be with us and contribute to an albeit slightly shorter than hoped Q&A session. I'm pleased to say that some of the main topics and conclusions raised will be published in the upcoming issue of the International Journal on Hydropower and Dams. A freely available PDF version of that will be made accessible via the ICOLD website, alongside a recording of this webinar and the one which we hosted earlier last year. With further information on that and some concluding remarks, please just let me hand back to Luc and Paco. Thank you.
Okay, Steve, thank you very much for your contribution moderating this session. It has been an excellent opportunity to share the experiences from others into the ICOLD team. And just as a concluding remark, because we've run out of time already, I would like to summarize saying dams can play a significant role in sustainable development, but their implementation must be carefully considered to mitigate negative impacts and ensure long-term benefits for society and environment. A holistic approach that considers the full cycle of a dam and reservoir, incorporates diverse stakeholder perspective, and utilizes innovative technologies. This is crucial for achieving sustainable dam management. At ICOLD, we're researching tools and methods that can be applied to the assessment of the life cycle sustainability of dams and reservoirs. And this webinar has shown much remains to be done, obviously. The task is very complex. We have to identify the most critical aspects affecting the sustainability of dams and reservoirs in order to focus on them and reach practical conclusions. So here you have an email address where we will be grateful if you can send to us questions, feedback, comments, and suggestions after the webinar, and also to the ICOLD Dance Sustainability Initiative. So please use this email to communicate with us further. And with that said, just many thanks to all the speakers for their time. Sonia, Nicolas, Kimberly, Jean-Pierre, Alena, Bonaventure, Isabel, many thanks to Steve and Hydropower and Dams for their support. And many thanks to the audience, of course, for your interest and present and future contribution. Thank you very, very much. I don't know, Luc, if you want to add anything else to finalize. Okay, so that was. Thank you very much. See you soon.
Thank you, goodbye.
Thank you.